Huh? Not really. You know, people say pre-calc is harder than calculus. Mhm. I'm thinking this semester, next semester, I'll teach only algebra. That pre-calc.
And so I'll watch your lecture. What's miss and subscribe notifications on?
Thank you. I mean, turn on the notification because every day I upload so many videos from all of my classes. I know, so don't click on the bell icon. Don't. You'll get bored.
No, I want all. I must start liking it like crazy. I've been all. Like the chat. Get on TikTok. The TikTok now, and then they like this one short video on the top.
Okay, hello everyone. How are you guys doing today? Good. So our third exam, we only did second, right? So our third exam will be when you come back from Thanksgiving break. Our third exam will be after Thanksgiving. And then you have final. In-class exam, that will be the last one. And again, all the homework and quizzes are open till 10 or something this month. Please finish everything. And yeah, someone told me that if you do anything after deadline, then you're going to get 10% deducted from your entire score. So it's a bad idea trying to do them after the deadline. So in our last class, we started finding inverse. Do you remember finding inverse? Little bit. So we're going to two examples on inverse, and then we're going to learn new materials. Any question before we start? Any comment, concern, complaint? Not yet. About what?
So I was doing my math assignments right on cloud, and I couldn't graph. I don't know how to graph on math.
Which type of graph you're talking about?
I think it was 11.5.
Amula?
Are you sure? Yeah.
Okay, thank you.
You want extra credit?
Well, thank you. So we are on chapter 12, and I think it's 12.2. Yep. So after this, we're going to go to 12.3. So to find the inverse, first thing you have to do is you have to see the y. So if you don't see y, you rewrite f of x with y so that y is there. Why do you care about y? Because once you see your y, you have to switch y with x and then solve for x. Sorry, solve for y. So in the first example, on the right side, we have f of x equals 5x minus 1 divided by 6. Do we see y here? No. So we are going to rewrite this f of x with y, and we get y equals 5x minus 1 divided by 6. So we did step 1. Then what is our next step? So basically, we are going to swap them. X equals, oh, that's why I can see my screen. The light is on. Yeah, it reflects on my computer screen, so I can't actually see anything. So we have x equals 5y minus 1 divided by 6. So we are done in second step. The last thing is solve for y. So how can you get the y alone? Times 6, both sides, they cancel out. We have 6x equals 5y minus 1. Plus 1 plus 1. So 5y equals 6x plus 1. Divided by 5, divided by 5. So whatever we have here, that's f inverse of x. Easy, right?
They were swapped, like the 5x minus 1 will be the denominator.
Okay, one example. Tell me the example you have on your mind. Okay, so let's see. First, this becomes y, so y equals 6 over 5x minus 1. Then we swap x and y. So we get x equals 6 over 5y minus 1. Not a dead end. We follow the same steps.
Both sides about
5y minus 1, 5y minus 1. So they cancel out. So we have 5y minus 1 times x equals 6. If you want to get this y alone, what do you have to get rid of now? There are two ways you can do it. You can distribute and then do it, or you can just do it without distributing the x. Divide by x. X. So 5y minus 1 equals 6 over x. This is x. Plus 1, plus 1. So 5y equals 6 over x plus 1. Then you divide by 5. So y equals 6 over x plus 1 over 5. But it does look kind of bad, right? Like weird. So, so we, instead of division, what can we do? Division is another form of what? Multiplication with a reciprocal. So we can do the same thing, y equals 6 over x plus 1, but instead of dividing by 5, it can do times 1 over 5. And then you can distribute the denominator. It will look nicer. Y equals 6 over 5x plus 1 over 5, which looks much nicer. Multiplying by the reciprocal. It's weird. We actually don't know how to divide by a fraction. So instead of divide by a fraction, you always multiply by its reciprocal. Any questions so far? Then we have another one. F of x equals 2x minus 2 divided by x plus 6. So in this case, first you have to find the inverse and then replace your x in the inverse function with 4. Actually, you can do this two ways. Y equals 2x minus 2 over x plus 6. And then what? We swap. So in this example, you have to swap two things. I mean, three things. X equals 2y minus 2 divided by y plus 6. So first step is done, second step is done, and now our goal is to get the y alone. So what do you do?
Okay, so we'll do it times by y plus 6 both times.
Y plus 6, y plus 6. So denominator cancel out. And this time we are going to distribute because we have y on both sides. Xy plus 6x equals 2y minus 2. In the last example, I did not distribute because we had x on only one x. But here we have two y's. So we need to have all the y's together. Okay, then what?
Now we're gonna try to isolate the what you the y.
Mhm.
We're gonna add 2 to both sides.
Add 2, or you can subtract 2y from both sides.
So you do that.
So we get xy minus 2y plus the 6x equals negative 2. So we have y's together, but we also have something extra, 6x. So it's a third wheel. So we need to get rid of that. So we get xy minus 2y equals, oh, I have space, so let me just do it on the other side. Xy minus 2y equals negative 6x minus 2. And now you're at least happy we have y's together and everything else together. But how can you separate the y? If you divide by x, then how it's gonna get the y alone? Mhm.
And then you divide -6 by x.
But if you divide, you have to divide everything. X, 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 x. So does it help you? Amen. If you move the 2y, then y goes to the other side. But you want to y together, all the y's together. Because it goes to get the y alone.
Like that again.
We have to bring them together. How? There is a concept start with F, ends with R. What's that word? Good job. Factor. You have to factor out the y. When you factor the y out, what do you get? X minus 2 equals negative 6x minus 2. And now do you know how to get the y alone? What do you do? Divide by what? If you divide by y, how y gets alone?
That was a trick question.
Your idea is divide, okay, but divide by what? You're going to get this y alone.
Oh, divide by x minus.
Divide by x minus 2, not y. And now you have y alone and negative 6x minus 2 divided by x minus 2.
You can't cancel out the x minus 2 and x minus 2, right? Because -6 is attached to that, right?
What's the difference between this one and this one? Are they same? Are they same? Of course they are not same, right? Because here if you distribute, what do you get? Negative 6x plus 12. So is negative 6 isolated from x minus 2? So you cannot cancel x minus 2 because they are not separated. They are If it was, then you could cancel. No, you have the coefficients. If, okay, only if you had y equals -6, x minus 2 divided by x minus 2, you could cancel them, and your answer will be y equals -6.
No, but I was, that was.
But this is not the case. So
X minus 2 over X minus 2.
so what is x minus 2 divided by x minus 2?
No.
See, so how can you get 0? Y equals 1. You cannot get 0, at least you get 1. So this thing is f inverse of x equals -6x minus 2 divided by x minus 2. Exactly. We are not done because they're telling us, hey, once you get to inverse, substitute x with 4. So, oh man, I hate that. No. Let me close it and get it again. The f inverse of 4 means -6 times 4 minus 2 divided by 4 minus 2. So you're replacing all the x with 4. And then simplify. What do you have in the numerator? -24 minus 2 divided by 2. And what is -24 minus 2? -26 over 2, which is -13. But this is not the only way of doing it. This is not the only way of doing it. There is actually a much simpler method. Can you think of the much simpler method? It has to do with the thing, with the information is that if f of x equals y, that means f inverse of y equals x. It has to do with this information. If f of x equals y, then for inverse, they reverse their position. Now, can you think of the easier method? Still no? We don't have to use this method to get the answer. There is a simpler method. And that simpler method has to do with this information. If f of x is y, then f inverse of y is x. Did you remember the connection between f and its inverse? The domain for f is the range for its inverse. So whatever you have for domain in the f, that's the same thing as the range of the inverse. Vice versa. The y value for the f is actually the x value, x value for inverse. Eliza. So they gave us f inverse of 4. So how you're going to do, how you're going to connect this in the original equation? So if f inverse of 4, let's say we don't know, something star, we don't know. How can you connect this with the f function? f of x equals 4. So whatever you here, that goes inside your f function, and whatever the inverse function goes on the y value for the f function. What does that mean? It means our f of x, which is x minus 2, x plus 4, x plus 6, x minus 2 over, wait, what? 2x minus 2. 2x minus 2 over x plus 6, right? Is 4. Because they told us f of x is that thingy, 2x minus 2 over x plus 6. They gave us this information, and they want us to find the inverse of 4. Basically, it means the y value for this function is 4. If you can figure this out, your life is easy. What do you have to do to solve for x? Multiply by x plus 6. So you get 2x minus 2. You distribute 4x plus 24. See, it's much simpler than what we did. And then what do you do? Subtract 4x, subtract 4x. And you can add the 2 at the same time. So this cancel out, this cancel out. We get negative 2x equals 26 divided by negative 2. And we get the same answer as before. See? How simple is it? Second method. You just have to remember the x value for the inverse is the y value for your original function, f of x. So if they're asking, hey, find the inverse of 4, so this is same as f of x is 4. So x value for the inverse is actually the y value for the f function. That's the trick. Hi, Rose, so nice to see you without your tablet. Thank you. Any question? Any comments so far? So you're done with inverse, and now you're going to do exponential function. Exponential function has a format where x is on the power. So all this time we never had x on the power. We had x on the base and our powers were numbers. But now the situation is reversed. The x is on the power and the number is on the base. Then it's called exponential function. For example, if you have x squared, it's a parabola. So it's a polynomial. But if you reverse their position, 2 to the x, it's not a polynomial anymore. It's exponential. Okay, so every exponential function has x on the power. So it's a new family of function. Just like parabola is a family of function. Exponential is a family of function. It has its own rule and own everything. Now, just like parabola, the format was y equals ax squared plus bx plus c. So sometimes we had leading coefficient that was not 1. Sometimes our leading coefficient was 1. But there was always a leading coefficient. Same situation is for this function. We have to have some type of leading coefficient. Sometimes it will be 1, sometimes it will be not 1, other numbers. And we have a base. The base is a number, not any variable, it's the number. So we have a leading coefficient times a number to the power x. Now the base can never be 0. If base is 0, then it's not an exponential, because 0 to the power anything is 1. Sorry, what I'm saying. 0 to the power anything is 0. You didn't even listen to me. You are just talking with him, talking with Jack. So I'm saying, just like parabola, we have a new family of function. It's called exponential function. The format for exponential function is y equals a, which is the leading coefficient, times b to the x. B is a number that is not 0. It could be whole number, it could be fraction, it could be decimal, it could be anything, but it cannot be 0. And we have special type of base, it's called e. So y equals a times e to the x. That e is a special number. Its value is an unlimited number, 2.7, blah, 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 blah. That e we call natural base. It's a different type of number, and its name is natural base. Just like before, when we have power, the power told us how many times you have to multiply the base. So here, the same scenario. If you replace x with a number, all you have to do is multiply your base power many times. Okay? So the first one says we have a function f of x equals 5 to the x. So our base, what is our base here in this case? 5. And now they're saying, hey, find f of negative 2.
It's easy. One is pretty hard.
Good job. So we have 5 to the power negative 2, because this x is negative 2. And then you have to simplify. It's a negative power, right? So how do you convert negative into positive power? 1 over 5 to the positive 2. And just like Gur says, the final answer is 1 over 25. Nope. It's a fraction, and we have no problem with this fraction. It's not reducible. The next one says find f of 0. So what do you have? Guys, what is f of 0? What is anything to the power 0 is? Really? 1. You already forgot your exponent rules? You know what? You know what? Next class, you're going to have a quiz on your exponent rules.
No.
Remember the 35 charts, 35 questions? I'm going to ask you all the exponent rules. There will be not 35, but less than 35. Okay? Next class, quiz time.
Yes. No.
The exponent rules from exam 1. Study all of them. I'm going to give smaller amount, not 35. Because you need to refresh your exponent rules. I wanted to give them in the exam, but then I decided to give you as a quiz instead of exam. So your quiz, exponent rules, next class. The last one is f of 2. So 5 to the 2, and what is 5 to the 2? 25. So observe what is happening. When you have a negative power, it's a fraction. When you have a positive power, it's a whole number. Now the graph, how the exponential function looks like. So we know x squared is a parabola. So the exponential, it's not a parabola, it has its own shape. Now, depending on what type of base you have, its shape is different. If you have a shape that is positive, if you have a base that is positive, anything bigger than 1, positive whole number. If you have something that is positive, your graph will increase. So when you go from left side to the right side, it will go up eventually. The difference between polynomial and exponential is that exponential grow really fast. Did you ever hear the expression, it grows exponentially? What does that mean? It grows really fast. The rate of change is very fast compared to polynomial. Polynomial grows or falls really slowly, little by little. But exponential, it jumps high really fast. That's why they use the expression, something is growing exponentially. Like virus, it's spreading exponentially because it spread really fast, like corona.
Okay.
It grew exponentially really fast. And then if you have your base that is a fraction or decimal less than 1, so any positive fraction between 0 and 1, then you're going to go to the other way around. You're going to slow down really fast. I mean, you're going to go down really fast. Okay. Decay function. So when the base is a whole number, positive whole number, it grows really fast. But when the base is a fraction between 0 and 1, it goes down really fast. They all type of exponential function without any transformation, they always go to the y value 1. It means when x is 0, your y is always 1. For example, here, when x was 0, our y was 1. So it doesn't matter what type of exponential function you have. If you don't have any transformation, then for every x value, your y has to be 1. So every exponential function, whether it's increasing or decreasing, they will go through the y value 1. That's the y-intercept. Unfortunately, they don't have x-intercepts. That means they never cross the x-axis. They will always lie above the x-axis without transformation. But when you do the transformation, that's a different story. Without transformation, the exponential graph always have y-intercept 1. There is no x-intercept. So they're always positive. Questions so far? So domain is from negative infinity to positive infinity. It means any x value you can substitute your x with. And your range is just like parabola. It depends on the lowest one. So since you can never cross the y-axis, so your range starts from 0 and goes upward. And since you can never actually have a 0, so we have a parenthesis for the range for 0. Means you can go up to 0, but you can never touch 0. Okay. Example, 2 to the x. When you have 2 to the x, 2 is a whole number, more than 1. So it will go through the y value 1, and then since it's positive, bigger than 1, so it's an increasing function. So you start from the left, you go up by crossing the y-axis through 1. This is your y equals 2 to the x. On the other hand, this is a fraction, less than 1. So it will be a decreasing function. Decreasing. Both of them are 1 to 1. If you do vertical line test, it's a function. If you do horizontal line test, it's a 1 to 1 function. So both of them are 1 to 1 function. But decreasing means you are going down really fast. So you start with something high, very high, and then you go down really, really fast. and your y value is still 1. The whole number base goes up, fraction base goes down. Any question? And you have to memorize this, or at least remember these shapes. They always give one question from either exponential or the opposite of exponential is log. So you're going to have one of these in the exam. I mean, the final exam. Definitely in the in-class exam. Okay, so since our y value cannot cross the x-axis, that means we have a wall, we have a boundary. The last boundary it can reach is the y-axis, the x-axis. And anytime there's a line you cannot cross, we call that asymptote. So all the exponential functions, they have an asymptote here. So we have a horizontal asymptote. Without the transformation, our horizontal asymptote is the x equals 0 line. This x-axis, so we have x equals 0 here. Sorry, what I'm saying x equals 0. Oh man, y equals 0. So y is positive here, y is negative here. So y has to be 0 in the middle. So every exponential function has a horizontal asymptote y equals some number. If you don't have any transformation, it's y equals 0. But if you do have some type of transformation, then how do you get the asymptote? It's y equals which number? Y equals your up-down shifting, the vertical shifting. Whatever direction you're moving, upward or downward, that's your asymptote. Okay. So this one doesn't have any y up-down. So this is basically plus 0, right? So it means you are moving upward 0 units. So basically you're moving nowhere. So this function has an asymptote y equals that 0. My 0 looks like a power. It's a number, 0. When you have a transformation, this number will not be 0. It will be some visible number, non-zero number. So your asymptote, the horizontal asymptote will be that number, y equals that number. Now I will keep talking about transformation. We have the same type of transformation as we had before. First, we learned this transformation in chapter 3. Next, we learn in chapter 11 with the parabola. And now we are learning the same transformation again for exponential. Good news, they all follow the same rule as before. If you have a number next after your function, then you are moving up or down. Plus 2 means going up, minus 2 means going down. From your, I shouldn't say 0, 0 actually. It's from 0, 1, x is 0, y is 1. So basically you are moving your y-intercepts. So plus 2 means going up 2, minus 2 means going down 2. You are shifting your y-intercept upward or downward. And if you have a number next to the x, so next to x, then it's left, right, and left, right doesn't follow the direction. So plus a number on the x means you're going left, minus a number on the x means you're moving right. So hey, no fun. Okay, so these are the same information as before. Also, this information is same as before. If you have a negative sign in front of your function, that means it's a reflection about x-axis. So if you have an upward graph, it too will become a downward graph. The only new thing we have now is a transformation on the axis. If you have a negative number on the x. That means you have a transformation on your y-axis. So if you have a graph like this, and this is the y-axis, you reflect the graph this way. So an increasing graph will turn into a decreasing graph if you have a negative on the power. Because negative power is a fraction. And fraction base means it's a decreasing function. Okay? Clear? Now let's do some example. We have 2 to the x minus 1. The original function is 2 to the x. So we see the original function, and then we have a minus 1. So which type of transformation? Up, down, or left, right? Up, down. So minus means which direction? Up or down? Down. And the next one, plus means up. So you take the original graph, which goes through y value 1. This is without any transformation 2 to the x. Now you're taking this y value, the y-intercept, and you are shifting 1 unit down. And you're drawing the same graph again. So this is 2 to the x minus 1. See, without transformation, it cannot go below the x-axis, but with transformation, you can be anywhere. That means C have a vertical asymptote here. So not vertical, horizontal asymptote here. This is the line it cannot cross. And this equation is y equals -1. This number, why you are shifting up or down, that's your asymptote, -1. For the next one, oops. The normal graph goes through y value 1, 2 to the x. But this time you are shifting 1 unit up. So you're taking this y-intercept and shifting 1 unit up. So your new graph will go to the y value 2. So this is 2 to the x plus 1. And the line you cannot cross this time is this one, y equals 1. This is your horizontal asymptote. How did we get this one? From this transformation. Whatever you are transforming up or down, that's the line you cannot cross. So our graph always has to lie above y equals to 1 here. And for the first case, our graph has to lie always above y equals -1 line. So that's the last boundary you can cross. I mean, you can touch. It can touch, but it can never cross. Actually, it doesn't even touch. It has electric shock. If it tries to touch it, it gets shocked. That's why it can never touch it. You can go close to that line, but touching is impossible. Yes, it gets electrocuted. The next one, what type of base we have? Base. So do you get increasing or decreasing graph?
crazy. No, but I'll be there. Jack, bro. Jack, bro. I didn't even. That's got to go.
So find the base of the fraction, we have a decreasing graph. And this time, how many units, which direction you are going? Down 4. So you take your y-intercept, go 1 down, 2 down, 3 down, 4 down. And you reach here and you draw your graph. Why are you drawing the increasing graph?
How come it takes that way?
I made a mistake.
No,
So it goes down.
no, but I'm saying how come that down? You see how the first one, the two, those are going up, that one going down. They're both going down. Shut up. That one going down. You cannot see it correctly.
This one is going up because our base is 2, whole number 2. This one has to go down
Larger than one is going.
because it's half base.
It's not because it's going down. Because it's going move. If it's greater than one.
Increasing.
The underline. So up or down don't have to do nothing.
If you have a fraction base, then it's going down because fraction is small.
I know that's.
So it's decreasing. But when you have a whole number, it goes up. Going down.
That's what I'm telling you.
So which line it cannot cross? What is its boundary?
Negative 4. Why is it?
So 1, 2, 3, negative 4 is here. This is the line it cannot cross. Y equals negative 4. For exponential graph, you always have to indicate your wall, your boundary. What line it cannot cross? And then the next one going up, so I'm skipping that. Instead, we are going to do horizontal shifting. Now we have a number next to the x. So if you have a number next to the x, which direction you move? Up, down, or left, right? Left, right. The minus means which direction?
Right to right.
It's right because it doesn't follow. Remember the heart, the girlfriend?
Yeah.
When the person gets inside your heart, they don't follow your direction anymore. So -1 should go left, but it doesn't, it goes to the right. +1 should go to the right, but which direction it goes?
Left.
Left.
But I would have left the heart one.
It's still inside the heart. That's why it doesn't listen to you. If you tell it to, hey, go right to 1 unit, it goes left 1 unit. If you tell her, hey, don't spend any money, she's going to spend all the money. If you tell her, hey, spend so much money, she's going to become stingy. Exactly.
I go down that.
So let me draw both graphs on the same plane. The original one, since 2 is a whole number, so it will be an increasing graph. 2 to the x. Now this graph is going right 1 unit. So you take this y-intercept and you go. Yeah. You take this point and go right 1 unit, and then you draw the same graph. So this is 2 to the x minus 1. Then for left, you take this and go 1 unit left. and you draw the same graph. 2 to the x plus 1. Now, all of them, what is their boundary? What is their horizontal asymptote? Remember, the boundary comes from the up-down. Y equals 0 because it did not have any up-down boundary. So up-down shifting. You only had left-right shifting. You didn't go up or down. So boundary is the y equals 0 line. Any scenario. If you don't have an up-down transformation, that means it's y equals 0. But if you have an up, that means y equals that number. If you're going down, it's y equals that number. And if you're not going up or down, so it's y equals 0. This is your boundary. Now the next one has base E. What is E? 2 point something, right? So are you going to have a whole increasing graph or decreasing graph? It's more than 1. Increasing. Any number more than 1 will be increasing graph. So we are going to have an increasing graph, and you have to memorize that or have practice. I mean, you don't have to memorize that. 2.7 is fine. You just have to know it's more than 1. Okay, that plus 1, is it left-right shifting or up-down shifting? It's with next to the x, it's with the x. So you're going to have a left shifting. That means the next one will be a right shifting. So let me do the same thing. Draw one graph. The original one goes to the y value 1. So this is e to the x. You're taking this, going 1 unit left. Then you get e to the x minus 1, so plus 1. You take this and go 1 unit to the right. Then you get e to the x minus 1. And what is your asymptote, the horizontal asymptote? Which line? 1? No. Did you go up? Did you go down? Then what is your shifting for up, down? 0. We didn't go anywhere. So it's same thing as before. Y equals 0. Horizontal asymptote. Horizontal asymptote. So in the exam, you're going to, you'll be asked to find what the horizontal asymptote and what the different types of transformation. Okay, the next one. We have a negative sign, it's reflection. So this negative sign, is it in front of the function or it's in front of the x? Which one? Function. So if you have a number negative in front of the function, which type of reflection we get? Reflected about x-axis or about the y-axis? X. If you get confused, remember about a parabola. X squared is this, negative x squared is that. So you reflected about x-axis. So this concept goes for true for any function. If you have a negative in front of the function, it reflects about x-axis. So this is a reflection about x-axis. The original one is an increasing graph, 2 to the x. If you reflect this about here x-axis, what type of function you're going to get now? So if x-axis is your mirror, so how are you going to reflect this graph? It goes through which y value now? Currently, it goes to the y value 1. If you reflect, it has to go through -1. So it reflects to get the same point on the other side of the x-axis. So this is negative 2 to the x. So all the number, they are the same number, just the sign difference. The +1 turns into -1. If you have a +2, it will turn into a -2. On the next one, where is the x? Sorry, where is the negative sign? In front of the x. So which type of reflection you get? Reflection about x-axis or y-axis? Y-axis. So the original one is increasing because it's 2. And if you reflect about y-axis here, what type of graph you're going to get? You're reflecting about y-axis. So this portion, the right side of the y-axis, will go on the left side of the y-axis. So this side goes down. So an increasing graph turns into a decreasing graph for a negative power. And it's true because negative power means what? Fraction, right? So anytime you have a fraction base, it's automatically decreasing power. Sorry, decreasing function. So you still go to the y value 1, but this time you're going down, not going up. Who is lost? Anybody? Cairo, no fun. Zohaib, no fun. Just because you have a notebook, it doesn't mean I don't see your phone. No fun, please. Now it's a combination. So try them. I have 4 of them. So first try the first 2, and I'm going to flip. You can try the next 2. And let me take the attendance. Can I flip my page? Are you guys done copying the left page? Okay. So try all 4. Today is 11 what? 11/4. Krish, absent. Jack here, Eliza here, Karen here, Alana here, Maria, absent. Daisy here, Justin here, Pachum here, Alira here. Oh, you change your seat. Hiba, yeah. Shahida. Hiba, why is Shahida? Oh yeah, she told me, I forgot. This week she'll be absent. Lois Bell, Marlene, Cairo here. Cairo, what are you doing? Why is it notebook? Draw them. You should see them while drawing them. Jiajun, Valerie, Yeri, no fun. You had fun before, but yeah. Amar, what are you doing?
Yes, I was mentally going in my head. I promise.
Amen, yeah. Nihan, yeah. Nihan, where is your notebook?
This, you gotta.
Guys, please don't do that. You need to watch what you are doing. You need to see them.
I can do anything. I think I will turn. Actually, do it better on.
Ingrid, yeah. Sophia, Antonella, here. Good, here. Ronald, here. Ibani, here. Zohaib, here. Terrence, absent. Okay, people who are drawing them in your head, who wants to come first?
I do first.
Come here.
Come up.
Draw it on my screen.
I'm not over like.
And I want to see what you have in your head. So show me what you have in your head. Come. Or if you don't want to do it on my screen, no problem. I have marker. Yep. Mm-hmm. There is no black.
Start off with the two right here.
You just told me you're doing in your head. So now why?
Go right two. Up two. What?
So draw the graph.
Right one is up. Right one up two.
Draw it. Come.
You go first and I go second.
You have notebook? He has notebook. No, Amar. Go ahead, Amar. And then Nihan and then Cairo. Nihan and Cairo, both of you. So actually, if you guys want to go together, I mean, no, we don't have enough marker. Exactly.
Now on the thing.
Sure.
This one. So.
The left hand.
My fault.
Yeah, that's case sensitive, no problem.
Alright, so this is two right here, right?
Let's do the original one.
Why are you drawing? I'm doing the two already, the original one.
The first original one. Here. And you mark it to the X.
Two to the.
You wrote 2x. It's not 2x, it's
Oh,
2 to the power.
How do you erase? How do you erase?
That's the eraser.
This one? I'm practicing, so. 2 to the X, right? Okay, I see. Oh, I did it already.
Okay.
I 2 to the X, right?
And now the transform.
And then the next one will be 2X.
Which direction you are moving?
Right one, and up 3, right?
Okay.
So it will be right 1. I'm bugging.
Right?
Yo!
One.
Chill, y'all put me under all this pressure, but right here, right 1.
He said right one.
And then 1,
2.
Two steps.
What do you mean mark it?
Don't
All right,
do the
2.
mark them.
Oh, no.
Hold on.
Frying you, I'm helping you.
Oh, now you dead not frying me. Never, never, never. I ain't playing with your life.
Rain.
Ah, yeah, 1 right here.
No, that's 4.
How is it 4? How is it 4? From 2x you go up there.
So draw your right one from your y-intercept.
So you want me to draw 3 lines? 3 lines? All right, that's crazy.
So first the right step.
All right, so the right step. Hold on.
Mark your right step.
Okay. So right here. So right one. This would be where the second.
Hit. And then from here.
You want me to draw the line?
Yes, to the dot.
She said draw the line.
To the dot, you step.
God, huh?
So every step you are taking, you have to mark your step.
Okay, hold up. Wait a minute.
So first you're taking right one, so go ahead.
Okay, I'm right one. Mark it right here.
Now from here, which
1, 2, 3. It's going up 3.
yes, so you want 1 right and then 3 up.
Exactly.
Oh.
Am I right or wrong?
Right.
I'm right. I'm right. So y'all over here. Y'all over here talking about the wrong thing. Yeah, it is true. It is.
Three exponential graph goes to the y value 1. Everyone. So this is the original y-intercept. You want 1 right and then 1 up, 2 up.
So, he's signing the board.
Hold up. Hold up. Let me cook. All right, right here.
Now draw it up.
No, you're right. Bro, no.
Oh shit. How do you erase? Yeah. All right. X minus 1 plus 3. That's right. What do you mean? Why does it only have? Oh missed. You gotta pick me today. Hold up. Okay, now what? Now what? How do I erase all of this? This is all confusing.
Down.
Just
You
draw.
just have to keep going from left. From here.
What do you mean?
From this point, go to your left.
What you mean? Go to my left?
You're more, bro.
See, every graph is
Oh,
continuous.
okay, so like.
And now you have to draw your asymptote. Which
Asymptote?
you cannot cross.
You cannot cross
Which line?
3.
So you have to draw at
You
that.
cannot cross. So wait. So I draw the dashed line, whatever it's called, right here, like this.
Which line?
Huh?
Which line you cannot cross?
What you mean? That's the line that that's what you can't cross though.
So which line?
The 3.
Okay, but you are crossing your graph.
Oh, okay. So draw another line. I'm gonna draw another.
And your graph has to lie above that
Okay,
asymptote.
I see. So another above, under.
So first question.
Yes.
So what's the line?
Y equals 3.
So where is y equals 3? Are you sure?
No, that's why.
Right here, right on the thing. No.
Look at the graph. Why is y equals
Right
3?
here. Right here.
Where?
Shut up, I know.
See?
I know.
And this line should be dot, not solid line.
This is what we're getting, right?
Exactly.
And it's y equals 3.
Mhm.
Okay.
Good job.
Thank you. Hold on, let me write my name. Oh,
Nihan.
you want me to turn on the mic, man? The mic? The mic?
Okay.
Neha.
The next one.
Oh, no, that's like, oh my God. You know, right? The
Alana? Yes. Go back to the last slide. Last slide. Yeah, give me 1 second.
X, and then you go to the left one,
Mm-hmm.
and then down 3.
Upside down. Okay, so that's what I meant. How is it? How is it like
3,
like this?
like that,
Good.
and then
And then you
the
have to
verb.
go which line you cannot cross.
Nah, must have me on.
-1.
No.
I don't know. I'm not gonna lie.
Which type of line? I mean, how can you get the line you cannot cross? Amen.
How stretch? Nah, he said that go up next. Yeah.
It's your up down shifting. So how many units you went down?
3.
So your line that you cannot cross should be
I don't know.
y equals -3.
Oh, y equals -3. So then I write a line. I draw a line where?
Y equals -3.
Okay, right here.
But that means your graph has to lie above that line.
Okay.
So why your graph is crossing that line?
I don't know.
So you have to erase your graph and redraw nicely.
Okay.
Mhm.
That's fine.
So you have to write y equals -3 on the line,
-3.
and it should be dot dot, not a solid line. So you draw a solid line, that line should be dot line.
So I erase it again, or I'll just use like red or something. Yeah, that's fine, right? That's good.
Good. Yes. That's all right. Cairo. Mhm.
Now we just. No, you got this. Yes.
Mhm. So
This
first
is
with the original graph.
Original graph. It's like one down, right?
No, original graph goes through which y value?
Is that how?
I don't know.
No, you don't.
Does it go this way? No. Shut- yo.
The original graph.
Like this way.
No.
Yeah.
Okay.
Yeah.
But which y value?
Which y value? 3, 2, 1, 1.
Yo, I'm coming back with you.
He was testing me. But it is not 1, right? What is the y value?
0.
Every
How do I go back? How do I erase?
It is.
Hold up. Okay, wait. I gotta go back now.
Now you're choosing your answer.
Actually, so I don't know. Can you walk me through it?
Sure.
Walk me through it.
Ask you to do the original graph.
Okay.
So every original graph goes to the y value 1.
Right, so I make 1 here, right? And I go up.
No, first you have to draw the original graph. See, this is original graph. This is original graph. So
So
you're
is
going
it-
to draw the original graph. It should be an upward graph because E is more than 1.
So
Anytime your
it's
base is more than
exponential,
1, it's increasing graph.
like that.
It goes on the left. It's continuous graph.
Hmm?
It's a continuous graph.
Oh yes.
You cannot stop.
That right.
Hmm?
Okay.
So that's the original graph, e to the x. So write e to the x on the top.
E to the x.
Okay. And now you're going to draw the transformation. What is the transformation?
So it's negative, right? So reflection
Good. Reflection about x or the y?
about x.
Good.
So it's this way?
No, this is a reflection.
Oh yes. Oh yeah.
Now this reflection, you're moving which direction?
Down.
How many units down?
1. From 0.
The number is
So-
here.
Oh, 3.
3
From
down,
So 1.
not from here.
No.
The reflection. This
So,
reflection.
yeah.
Which direction you're going?
Down.
How many units?
3.
So go down.
So this is 1, 2.
No, this is your reflection.
Okay.
This is the starting point.
Right. So
So from here, you have to go 3 units down.
1, 2, 3
And then which direction?
down like this.
No, you already went 3
Oh,
down.
left.
Then-
To the left.
So from you 3, go left.
So like here, 1, 2,
Okay.
and then like this.
It's continuous. You have to go on the left side forever. And then which line you cannot cross? What is your boundary?
This line.
Whoa.
This line.
So what is this line?
X. I'm not so sure. -2.
It's your transformation.
-3. -3. That's what I meant.
Y equals -3. So you have to draw a line at y equals -3.
So here, straight,
Why is y equals -3?
because this,
Where?
where, yeah, here.
The last one or the top one? Which one?
Like here,
So what's the y value here?
-3.
Count it.
Oh, here.
So you have to draw a dashed line on there. And you have to write y equals -3 on that line.
Alright, equal -3. I did.
See?
It's not that bad.
Next time bring papers.
Okay.
Notebook.
But you said no tablet, that's why I was like,
I said no tablet, but I didn't say no notebook.
I forgot to bring
Physical
paper
notebook.
and a pen.
Miss, can name it to the next one, please?
No, Eliza. Eliza said, right? You said you're going to do the last one, right?
There we go. Nah. There we go. No, not Elijah, because he had it saying, let Elijah do it, because you know he's not. That's good. Yeah, that's good. You see, we know. We go down 3 times.
In the final exam, we'll have at least one of these, either from the exponential or from the log.
Can we have that one?
That's the original.
So mark it. It's e to the x. Mark e to the x. Like you have to level your graph. Okay.
Oh, just reflect it. Go up. 1, 2, 3, 4.
No.
And then we reflect it over the.
Wait a minute, Sonny, wait.
Clear.
So basically,
So it's not a parabola, it goes this way. You have to draw it clearly. And mark your asymptotes.
all right, can you delete this so I can write the final product?
Square.
Hmm? This is the final product.
Hey, no, but you heard that. No,
And now draw the line that you cannot cross.
that drink at the water bottle.
Guessing you cannot cross.
Why? How many units you want up?
That's all we did.
Why not 4?
But count your lines. How many units you actually went up?
Oh, it has to be right here. Yeah, whatever. And then
Start, you can say your one is here. They don't have to erase.
okay,
So
And then-
what you cannot cross?
guessing you cannot cross y
The answer
equals
is in front of you. Y equals what?
y equals 4.
Good. So you have to draw a dotted line. Are you sure this is Y equals 4? Count your line.
1, 2, 3, 4. Oh wait, it's right here. This one, right?
Thank you. So in the exam, you have to draw neatly, guys, okay? So that I can see where you are crossing and which line is your boundary.
Miss, I think mine is the.
Not bad. Because now you know how hard it's to draw this graph. Okay. So make sure you practice with these graphs. And make sure do the homework on 12.3. 12.3. This is 12.3. And we still are doing 12.3. 12.3. 3. We did 2 fast and then it's 3. Graph is 12.3. Okay, the next question. Well, depending on your calculator portion, actually this is not a calculator portion. Because previously you guys are allowed to use graphing calculator, but now you don't. So you're not allowed to use calculator, never mind. Good.
I think it's B.
B, why do you think that?
Because, the original graph, the original graph is at 1, 0, and so. That's 0. So it's minus 1.
And it shifted 1 unit down. Yep. This ln, this is ln, it means log. We didn't learn about log yet, so definitely it's not C or D. So it's either A or B. A is a transformation, it's a reflection. That reflection, sorry. A is a left-right transformation, and B is an up-down transformation. So if you look at the original graph, this is the original graph. So if you compare the original graph with the given line, given graph, you can see clearly it's 1 unit down. So it's B. Good. Any questions so far? No? So you've done a graph. So we learned domain, we learned range, we learned graphing, transformation, everything. And now, how do you solve them? How do you solve exponential equation? So just like polynomial equation, we have exponential equations.
Since the bases are the same, cancel out the bases and solve it like that. Yes.
Good job. So depending on what type of exponential graph you have, you follow different rule. The first rule says we have the same base. As long as you have the same base, we're allowed to cancel them for same base. Same base on both sides of equal sign. It means cancel them. So if you cancel the base, what is left on the left side? No, we have 2x, and then we have 3x plus 2. And it becomes a linear function. Minus 2x.
Minus 3, it works both ways.
You can do minus 3x, but then x becomes negative.
But it's not even.
I know. Minus 2 or minus 2 is just, I mean, you get the same answer. You get past 0 here, but you have 3x minus 2x, which is 1x plus 2. Minus 2 and minus 2. You get x equals negative 2. You can do minus 3x and then divide both sides by negative 1. One more. You know, the Thursday quiz will be on exponent rules. Actually, I should give one graph question and exponent rules. So quiz on Thursday, one graph, one transformation, and exponent rules.
But I like how you answer for quizzes, but the question is, do you pass them? I do pass them. You ask them for quizzes. I can't get on that damn page.
Okay, we'll stop here. let's stop here for today. Make sure you revisit your exponent rules, the rules you have on your exam 1.
That would be a good thing, good class.
Go ahead, Alana.
I don't know. How do you? Huh? What is it for?
It would be like classic.
Very career, man.
I'm going now.
So it's just like, so like, that's probably gonna know, doesn't mean we're gonna be the same thing, it's similar.
No, that's not.
It's not supposed to be out there, it's you're probably gonna be done right. Unless you're at odds and you get to make sure that you know. For now, it's only supposed to be. I don't yet.
You stay here, don't even say that. No, they like the end thing for
These chairs are horrible, like that table is horrible. Why, what happened? Because my pencils keep falling, my book keeps falling, it doesn't matter, I just have this, myself. I just have myself, my phone, my notebook, it's not even a big notebook, and this, and it always be falling, like.
If you feel comfortable, you can actually use this seat and use this desk. If you don't feel uncomfortable.
No, I would not rather be stared by the whole class. No, God forbid. They're gonna be like, why is it taking forever to make notes? Because I write this pretty slow. You guys be like 10 thumbs ahead of me, and I'm like, down. I didn't even put your pen. That's why I was like, well, cause like I would spend like 15 minutes on that. Like I should have taken a picture of it at this point. And I said, you know what, fuck it.